Hi. My name is Marko Švaljek, and today I'm going to talk to you about data modeling with Apache Cassandra. So let's start. A few words about me. I work as a software developer at the Machine Networks department of the Kapsch Group, and the company developed an Internet of Things platform focused primarily on intelligent transport, and uses Apache Cassandra for storing and processing the telemetry data coming in from various devices placed at vehicles like trains, cars, and trams. In June, I took part in organizing the Zagreb Cassandra Users Meetup. Oh, okay. Now can you hear me? Or? Okay. Sorry, I'm not used to this kind of technology. So, in June, I took part in organizing the Zagreb Cassandra Users Meetup and gave a talk there about Cassandra time series data. Now, let's say a few words about the Cassandra. First of all, it's a Java technology. It's been written in Java. Now, there are over hundreds of NoSQL solutions available today. Some of them are document stores, key value stores. There are also graph databases, and Cassandra belongs to a group called a wide store. Now, what's specific about Cassandra is that it's masterless. So there's no master node that determines where the data goes within the cluster. Also, there's a company called the DataStax. The DataStax employs most of the Apache Cassandra committers, and DataStax also has its own enterprise-grade Apache Cassandra distribution. Now, let's start with comparing Cassandra to the other data storage solutions. Now, Cassandra has no single point of failure because there's no master node. Now, it's also very easy to set up inter-data center communication and replication processes. It also has the linear scaling capabilities, and there are numerous tests around to prove that. So, Cassandra is also a NoSQL solution, but since it's NoSQL, does it have some kind of best practices with the data modeling? Well, there are some. So but first let's compare it a bit further to the data modeling, for instance, in the relational world. Now, the data model is highly denormalized. So having redundant data is nothing unusual when modeling with Cassandra. There's also no concept of foreign keys. There's no referential integrity, and there's no joins. But how do we go around all these flaws? So, when compared to the relational data, you have to think about the queries up front. So, it's not like in the relational world where you just think about the tables, you create the tables, then you fill them in, and then you think about the data that you're going to get out through the joins, etc. So, query first design principle. Now, unlike the relational databases, there's no penalty for the wide rows. So, in Cassandra, you can have really, really wide rows. And the other design principle is that the disk is cheap. Disk is considered to be the cheapest component in the whole data management system. And now you're probably thinking, okay, if everything is so redundant, etc., there are probably going to be a lot of writes. But with the Cassandra, it's bring on the writes. So, now, let's consider, have a look at the Cassandra objects that are actually used in modeling the data. At the highest level, there's a key space. Key space regulates the replication. Replication is simply a number of copies of the same data that are placed on the other nodes in the cluster. There's a term called replication factor. It's simply a number of those copies. Now, inside the key spaces, there are tables. Inside the key spaces, there are tables. And inside tables, there are rows. Rows are identified by primary keys. And Cassandra also knows the concept of the indexes. So, but we will come to that shortly. So let's have a look at the data organization at a bit higher level, and let's visualize it, how it actually looks. So just one more time to get you acquainted with that. So a key space, a table, row, and then a great number of columns. With the Cassandra, there can be up to 2 billion columns in a single row, and that's nothing unusual. Of course, you cannot just put a lot of data into it. For instance, if you have rows that are hundreds of megabytes wide, you're going to spend some time with transmission of data. So we have to avoid it and model around it. Now, let's have a look at the wide row concept. This all was presented with the big table paper from the Google in the year 2004. So we have a row identified by a row key, and then a very large number of columns. Now, every column contains the following data: a name, a value, a timestamp, and a time to live. Now, with the name and the value, that's pretty clear. So, except that Cassandra is actually a distributed system, so the data is not deleted right away. It is marked with a tombstone. So, for instance, the other nodes might think that this node actually missed a byte. So they would then recreate the same data that we deleted again in that node. So we're just marking the data as deleted. Now, Cassandra also uses timestamps to determine which data is the newest, because at the same time you will probably have multiple columns but with a different timestamp in it, and then timestamp is going to be used to determine which data is the newest. There's also a very interesting concept with the Cassandra, and that's that every data that gets inserted can get expiration time attached to it. That means we don't have to write data processing jobs that run during the night and that delete all irrelevant data. Now, Cassandra uses a Cassandra query language. It is very similar to the SQL, and because of that, it has a pretty nice learning curve, and unlike the previous versions of Cassandra, you don't have to read the code in order to find out about the schema and the data that is, and the structure of the data that is stored. Now, let's start with something very simple. Now, this is a simple employees table. We have a name, age, and role stored. Now, inserting the data also looks pretty standard. So, like in the SQL, the key difference between the Cassandra and, for instance, the relational databases is that inserting the values again with the same primary key is perfectly legal. So that's the key difference. Now that we've inserted the data, you can see selecting is also pretty similar to the way it works with the SQL. But if we now, for instance, try to select all of the employees that are older than the age of 20, this wouldn't be possible. But we'll come to that why it isn't. Now, Cassandra also has indexes, and we could index this table by the column of age, and then we could access the data and retrieve, for instance, the employees that are older than the age. But actually, this concept isn't recommended because then the index has to be built on every single node in the cluster, and it doesn't scale very well. So it's supposed to be used with the tables where you have around hundreds something of rows. So, but let's continue with a more complex example. Okay. Before that, we'll just have a little sneak peek at how it's actually stored on the disk. So we will have two rows, Tom and Mario, and every row is considered to be a partition, and there's actually no next row because the other row might be placed on a completely different node in the cluster. So let's go a bit further. Now, let's start with the employees too. There we'll have a company, a name, age, row, and primary key is going to be company and name. Now, let's insert some data, and this would look something similar to this. Now, remember, primary key is company, and name. Now, let's have a look at how it's stored on your disk. Now, one would expect that this data above would actually be 5 rows long, but it actually isn't. There are only 2 rows. If you remember, the primary key was company, the first part of the primary key was company, and the second part was the name. Now, if we didn't specify the name as to be a part of the primary key, we would simply have two rows inside, and that would be the Peter, because Peter would be over John, and Nina, because Nina is the last name. So the other part of the primary key is actually a clustering key. So this then causes the data to be stored in the following way. You have the John, and John is then combined with the column H, and you have it stored here. And then a big number of columns. Now, I know this might seem a bit strange and unusual, but this is how Cassandra works. Let's go a bit further, and perhaps this concept will become more clear to you. Now, actually, now that the rows are the rows in Cassandra are the columns in a row are always sorted, and now it's actually possible to select the values out based on, for instance, lexical comparison as shown here. Now, when we go into this while row, we can actually find, okay, there's a name that's lexically greater than Kate, and those two are Mario and Mona. Now, I would really like for you to remember this. So, primary key actually has two parts. I mean, the syntax is lexically the same as with the relational databases, but there are actually two parts. First is the partition key. It's going to identify the row, and all of the rest of the column are simply used for clustering within this while row. Now, let's continue and show how we're modeling the relationship within Cassandra. So to display this, we're just going to use simple online video viewing service. So we're going to have a table of users. Now, this doesn't look too out of the ordinary. The username, and every user is going to have its own row with their first name, last name, and email. Pretty standard. Now, we're going to create a table with videos. It's going to contain video data, but we would also like to have the username of the user who actually uploaded it. Now, this is not a normalized form because it contains the data from the user. It has an foreign key that goes into the table. We insert the data there when we need it. So, for instance, there's a design principle that, for instance, says that just put the data that you see on the screen in the row. So now, finally, we're going to come to the one-to-many relationship, and we're going to use some kind of index where we would like to see the videos that the user has. Now, it's going to have a username, video ID, upload name, video name, and now the username is going to be a key. So every user will have a row. And then inside this row, there will be a large number of columns containing all of the videos that the user uploaded. That's actually a one-to-many relationship. Now, let's take it a step further. Let's see how we would model the many-to-many relationship. Now, in a relational world, we would use a joiner table, and there we would have a couple of foreign keys with some data that we would want to write. In our case, this is a comment time and the comment itself. Now, with the Cassandra, it's being on the right. So we would actually create two tables, and there we would need it. So we would have comments by video. So when we would have a page containing the videos, we would have probably have the comments underneath. So we would create a table for it. We would have rows where the video ID is, and then we would have it stored by the username in a while row. Also, if we would like, for instance, to keep a timeline with the data, then we would, for instance, cluster by the comment time. It's also possible, for instance, to because timestamp has only a resolution up to a millisecond, but sometimes in a distributed system, a lot of things can happen within a millisecond. So there's actually a time UID type that it has a bit statistics involved, but the theory says that you cannot get 2 of them if you would write 10,000 data within a millisecond for 100 years. So there would be a chance about 50% for the 2 of the same values to be generated within the same time. And now let's have a look at the comments by user, and they're the same story. We have a username. Username is going to be a row, and then we're going to have a lot of videos within this wide row. Now, as you know, all of the data is kept sorted all the time. So within a row, columns are always sorted. Now, in some cases, like in live monitoring application, transactions, and that sort of stuff, you would want to reverse the ordering of columns so that you can fetch the beginning of the row more easily. Now, to do that, you are going to use with clustering order by class. And that would actually cause the Cassandra to store the row the other way around and not sort it. This about concludes the talk. And thank you for your attention. And I would like to open the Q&A session. Thank you. What do you mean, an example of a reversed wide row, or
all the tables that you create? All the tables that you've created, how would it look like in Cassandra when you would select it?
I don't have it here. You can send me an email and I'm going to send it to you. Okay.
So, what is the amount of data in your production database?
It's terabytes, but I'm not doing the administration, so I'm not really sure. It's terabytes, something like that. Yeah. But with the Cassandra, I mean, it can really scale. It's the Apple, for instance, has the installation with 75,000 nodes, and it's actually, I believe, 15 or 12 petabytes of data. So it really scales. It's a technology where the focus is more on writes, and it is used for applications, for instance, where you spend 90% of the time writing the data. It's that sort of, so high velocity writing, it really eats the data, so to say.
Did you try to solve this problem with relational databases, or did you start from scratch with Cassandra?
Now, we started from scratch with the Cassandra because we have a consulting company that actually recommended for us to use it. But I've looked a bit around, and for instance, with the proper amount of money and the expertise, almost anything will scale. So relational databases are still fine. There's no problem with them, but with the Cassandra, there's a really fast learning curve, and you can really easily set up the cluster. For instance, an unexperienced developer can set up a cluster with a couple of nodes within the minutes. It actually takes longer to download the Cassandra than to set up the cluster. So it's really easy to set it up, and for instance, to set up the inter-data center replication. And I've mentioned it earlier that, for instance, some kind of bad jobs for the expiry of data and that sort of stuff, the wide row data structure is actually pretty good at that. So it's more about the cost of scaling than it is that the relational databases don't scale that well or that sort of stuff. So it's a complementary technology, and we live in an era with a polyglot persistence. So it's perfectly fine to use Cassandra with the relational databases, and we actually do so. So we also have a MySQL database, and we're using it for the relational modeling of the entities, etc. So, but they really work well together. So, yeah.
That's all. Thank you, Mr. Švaljek. So if you have any other questions, I will give you a little present for every question. So it's about to be with Švaljek cup equipped. So please. No questions? Okay, thank you. We will proceed in around 10 minutes, so please go to your coffee or eat something nice. See you in 10 minutes. Thank you.